Good morning, class. My name is Bamishebi Samson Olabisi. I'm the editor for this CSC 204 Human-Computer Interaction. And so far, we are now in section 4, unit course 1, design of user and system interface. The introduction of the course, remain the same, and the course objective is still similar to the chapter 1, to section 1, section 2, and section 3. The learning outcome of study section 4, unit 1. By the end of this unit, it is expected that the student should be able to know the significance of user interface, to be able to explain the function of user interface software and explain the concept of user interface design, and understand user system interface, and to be able to also understand the concept of formality, evaluation, and describe interaction design phases. Introduction. Design of user interface concept. In this unit, it offers guidelines for design of user interface software in 6 function areas: data entry, data display, sequence control, user guidance, data transmission, and data protection. These guidelines are proposed here as a potential tool for designer of user interface software. Guidelines can help establish rules from coordinating individual design contributions, and help establish rules for coordinating individual design contributions, and can also help to make design decisions just once rather than leaving them to be made over and over and over again by individual designers. They can help define detailed design requirements and to evaluate user interface software in comparison with those requirements. The design of user interface software will often involve considerable investment of time and effort. Design guidelines can help ensure the value of other investments. In designing computer-based information systems, specialized attention must be given to software supporting the user interface. User interface design of information system. Computers today are used for a broad range of applications. User interface design guidelines cannot be applied usefully in every case. Some computers may be embedded as components in larger systems so that they communicate only with other computers and not directly with human users. When there is no user interface, then no user interface design guidelines are needed. To the extent that information systems support human users performing defined tasks, careful design of the user system interface will be needed to ensure effective system operation. The guidelines are intended to improve user interface design for such information system. What they are simply saying is that some user interface, based on the fact that they were used in a range of different systems today, so some of them might not need to interact directly with humans, so they were embedded in the system. So where the guideline is not needed, definitely there's no need to put user interface there. So these are the reason why some of them are embedded to reduce the how will I put it, to reduce the complexity of the design of system. Users of information system interact with a computer in order to accomplish information handling tasks necessary to get their job done. They differ in ability training and job experience. They may be keenly concerned with task performance, but may have little knowledge of interest in the computer themselves. Design of the user system interface must take account of those human factors. Or they are simply telling you that majority of the people that interact with the systems are not interested in that system itself. They only interested in carrying out their own task. And in as much computer can offer that support, that is what they are interested in. So the builder, the designer of user interface should factor that in, because some of them are not really interested in learning anything about it. They just want to carry out their tasks. User interface software. What sets data processing system apart as a specialized breed is a function of each switch button, the functional arrangement among the buttons, the size and distribution of elements within a display are established, not in the design of the equipment but in how the computer is programmed. The design in the programs equally establish the content of processed data available to the operators and the visual relationship among the data. In combination with or in place of hardware, it can also establish the sequence of action which the operator must use and the feedback to the operators concerning those actions. User interface design cannot be the concern of only the psychologist or the human factor specialist. It is a significant part of information system design that must engage the attention of system developers, designers, and ultimately system users as they were. In designing computer-based information systems, specialized attention must be given to software supporting the user interface. What they are simply saying here is that in designing user interface, it should not only be the job of psychologist or the human factor specialist. The designer must be involved. The user also must be factored in. So those are the things that you need to consider when you are designing a system. Special attention must be given software supporting the user interface. A comprehensive set of guidelines for design of user interface software. The computer-based information system exists in another unit of this study pack. Also, the general problem of user interface design and the particular need for guidelines to design user interface software are identified. So, information system and interface users. Computers today are used for a broad range of applications. I have said that one earlier. User interface design guideline cannot be applied usefully in every case. So some computer may be embedded as component in large system. I have said this one so that they communicate only directly with the system. To the extent that information systems support human user performance defined tasks, careful design of the user system interface will be needed to ensure effective system operation. Users of the information system interact with the computer in order to work to accomplish information handling tasks necessary to get their job done. they might not necessarily be interested in the system itself. So design of user interface software is not only expensive and time consuming, but is also critical for effective system performance. In a constrained environment such as that of many military and commercial information systems, users may have little choice but to make do with whatever interface design is provided. Yeah, there, the system of poor user interface design may appear in decreased performance, frequent and or serious error in data handling may result from confusing users interface design. Tedious user procedure may slow data processing, resulting in long queues at the checkpoint counter, the bank cashier windows, the visa office, a company security checkpoint, or any other workplace where the potential benefits of computer support are outweighed by an unintended increase in human effort. In situations where degradation in system performance is not so easily measured, system of poor users interface design may appear as users complaints. Yeah, what they were simply saying here is that the user interface must be designed in a robust way to factor in the traffic that human factor can generate. That is, in a military operation or in a commercial information system, if the system interface is designed poorly, definitely is going to affect the performance of such system, like visa office, cashier in the bank, and other. If those interfaces are poorly designed, then it will result into a long queue of human, and then that will affect the system, and degradation can also set in over time. The system may be described as hard to learn or clumsy, tiring, and slow to use. The user's view of a system is conditioned chiefly by experience with its interface. If the user interface is unsatisfactory, the user's view of the system will be negative regardless of any nicety of internal computer processing. A data entry application in which relatively simple improvement to user interface software, including selection and formatting of display data, consistently in wording and procedure, online user guidance, explicit error message, re-entry rather than overtyping for data change, elimination of abbreviations, etc., resulting in significant improvement system performance. Data entry was accomplished 25% faster with 25% fewer errors. How can that kind of design improvement be achieved in general practicing? What they are simply saying is that no matter what you design as a designer, in as much the system is not robust, it allows delay, it could not tolerate error. Definitely the user will view that such system as a poorly designed system or a poorly designed interface. User interface software design can be regarded as an art rather than science. As an art, user interface design is best practiced by experts, by specialized or specialists experienced in the human engineering of computer systems. Most established information systems call for a system development sequence starting with requirement analysis, functional specification, and verification before any software design begins. The actual cost of user interface software development will sometimes depart from that desired sequence. There may be no explicit attempts to determine user interface requirement. Specification may include only rudiment reference. Rudiment reference. Used user interface design rudiment reference, where user interface design with general statements that the system must be easy to use. In the absence of effective guidance, both the design and implementation of user interface software may become the responsibility of the programmer unfamiliar with operational requirement. Detection and correction of design flaws may occur only after system prototyping, when software changes are difficult to make. In this phase, the user interface specified sketch developed and tested. The goal is to support the identified issue during context, task, and user analysis, and to meet the human computer interaction evaluation metrics requirement. Design is also based on accepted conventions and experience. The main activities are interface specification and formative evaluation. Interface specification include semantic understanding of the information need to support system requirement and HCI analysis result. The syntactical and lexical decisions include metaphor, media dialogue, and presentation design. Details of these are given below. Metaphor and evaluation design. Metaphor and visualization design help the user develop a mental model of the system. It is concerned with finding or inventing metaphor or analogs that are appropriate for users to understand the entire system or part of it. Well, accepted metaphor include a shopping cart for holding items before checking out in e-commerce context, and light bulb for online help or daily tips in productive software package. Media design. The media design is concerned with selecting appropriate media type for meeting the specific information presentation needs and human experience need. Popular image, e.g. video clip and animation and sound. The bandwidth needed for transmitting information depends on media type. In addition, some media types contain effective qualities that can make presentation more interesting and stimulating or annoying and distasteful. Dialogue design. Dialogue design focuses on how information is provided to and captured from user during a specific task. Dialogue are analog to a conventional between two people. Many existing interaction styles can be used, such as menu, forms, menu, language, and dialogue pauses and direct manipulation. Presentation design. Presentation design concerns the decision on information architecture and delay layout, incorporating metaphors, media, and dialogue design with the rest of the display. Commonly established user interface design principles and guidelines may be applied during the design stage. Decision of information architecture and display layout incorporating. For example, the following presentation design principle was suggested by Sutcliffe in 1997. Maximize feasibility. This means all necessary information should be immediately available. Minimize search time with minimum keystroke. Provide structure and sequence of display. Focus on users' attention on key data. Here, important information should be salient, easily comprehend. and then provide only relevant information, and 6. No overloading of users' work memory. Formative evaluation. Formative evaluation identifies defects in design, thus inform design iteration and refinement. A variety of different formative evaluation can occur several times during the design stage to form final design decision. In fact, we propose that formative evaluation occur during the entire ACI development life cycle as depicted below: design, prototype, evaluate. Okay, done. Then if it is not, redesign again, prototype again, and evaluate. That's what they mean. So if you are not satisfied after evaluation, you redesign, then you re-prototype. When you re-prototype, you evaluate again. If there is one or two things that need to be fixed again, you redesign until you are finally satisfied. In conclusion, current user interface and their underlying system are just too frustrating for software developers. Should be to increase the reliability and usability of user systems, reboots, application crashes, and incompatible file format that stop users' tasks must be what? Reduced. Then the incomprehensible instructions, ambiguous menus, and trouble dialog boxes need to be revised to enable users to complete their work promptly and confidently. Long download time of web pages, drop sections for network application, and disruption caused by unsolicited email, spam, and destructive virus. As the number of users has grown, all these problems have become more serious. Novice users want the benefit of email or web services, but they are the poorly equipped and motivated to overcome the problem that high-tech early adopted proudly conquered. Improved training can help, but improved desire an important component of making the next generation of users interface more appealing and then more satisfactory. In summary, user system interface include all aspects of system design that affect system users, particularly on those design features of the user's interface that are implemented via software. Special attention must be given to software supporting the user interface and other physical and human factors influence other user performance. The user's view of system is conditioned chiefly by experience with the interface. User interface design is best practiced by experts, by specialists experienced in human engineering of computer systems. The interaction design phase is made up of metaphor and visualization design, media design, dialogue design, presentation design, and formative evaluation of the design. I think with this, we have come to the end of this class. Thank you for listening, and I appreciate it. We'll meet in the next class. Thank you.